All right, let's talk about something that is an absolute game changer in programming. It's the one concept that can take your code from a tangled, confusing mess into something, well, elegant, a masterpiece even. We're talking about functions.
You know the feeling, right? We've all been there. You start a new project, everything's neat and tidy, it all makes perfect sense. But then you add a new feature and another, and pretty soon your script is this giant, sprawling thing that's a nightmare to manage. So, to really get a feel for this problem and how to fix it, let's use a real world example a company that makes custom tents.
Okay, so to figure out the price for one of their tents, this company needs to do a few calculations. First, the area of the canvas, then the cost of that canvas, and finally, they have to slop on an 18% tax. The first instinct, the hard way, is to just write it all down in one long, continuous block of code, one instruction right after the other. And this is basically the two roads you can take. On the left, you've got that brute force method. It's just one long to-do list for the computer. Sure, it works, but man, is it hard to read? It's tough to fix when something goes wrong. But then look at the right. This is the modular approach. It's so much cleaner. The main program just calls on these little specialists, a function to handle the cylinder part, another for the cone part. It's simple and it's readable. And that smarter way of doing things, that's what we call modular programming. Its secret weapon, its superpower, is the function. The whole idea is to take a big, complicated problem and just smash it into smaller, bite-sized pieces that are way easier to handle. So what is a function exactly? Well, think of it as a little mini program. It's a block of code that you give a name to, and its whole purpose in life is to do one, and only one, specific job. You write it once, and then you can just call it by its name whenever you need that job done. And this, right here, is where the magic really happens. This is the single biggest reason functions will change your life: reusability. Once you've written a function that, say, calculates the area of a cone, you never have to write that piece of code ever again. And the benefits? Oh, they hit you right away. Your code instantly becomes easier to read. It gets a whole lot shorter because you're not repeating yourself all over the place. And finding bugs, it's 1,000 times easier when a problem is trapped inside one small, specific function. Plus, like we said, you can reuse them everywhere. And if you're on a team, you can divide up the work. You build one function, I'll build another. It's perfect. Okay, let's jump back to our tent company for a sec, because this is where the power of reusability really shines. Let's imagine their design team comes up with a new tent. This one has a rectangular base, but it's still got that same pointy, conical top. Now, if they'd used that clunky, long script, this would be a headache. They'd be copying and pasting and trying to change things without breaking something else. But with functions, it's a piece of cake. They already have a function that knows how to calculate the cone. They just reuse it. No rewriting, no fuss. All that time is saved, and there's way less chance for new bugs. All right, so we get the why. We know functions are awesome, but how do they actually work? Let's pop the hood for a minute and see what's going on inside. You're going to hear these two words all the time: parameters and arguments. And honestly, it's super simple when you think about it like this. The parameter is the parking spot. It's the empty variable waiting inside the function's definition. The argument, that's the car. It's the actual value, the actual piece of data you send to the function when you call it. The car pulls into the parking spot. Easy, right? So your function does all this work. But then what? How does it give you the answer? Well, that's where the return statement comes in. If your function is a recipe and the arguments are the ingredients, the return statement is the finished dish. It's the result that the function hands back to your main program. Now, this part is absolutely crucial to get. Your program is just chugging along, reading from top to bottom. Then, bam, it hits a function call. At that point, the whole program pauses and jumps over to where you defined that function. It runs all the code inside, and when it hits that return statement, it jumps right back to the exact spot it left off, usually carrying the result with it. It's like a quick little side quest. Okay, and now for the best part. Seriously, you don't have to write every single function yourself. That would be exhausting. The great news is Python comes with this massive, built-in toolbox of functions that are ready to go. These pre-made functions live in files called modules. You can think of a module as a specialized cookbook. There's a cookbook for math recipes, another one for random number recipes, one for statistics. You get the idea. It's a whole library of toolkits. And just look at this. This is just a tiny little sample. The math module has functions for things like square roots. The random module can just spit out a random number for you. Need the average of a bunch of numbers? Don't write it yourself. Just use the statistics module. You just type import, tell it which cookbook you want, and boom, you've got all these new superpowers at your fingertips.
So look, what I really want you to get from all this is that functions are way more than just a trick for organizing code. Learning to use them, it actually changes the way you think about solving problems. There's this great quote from computer scientist R. Tarjan that just nails it. The computer doesn't need to understand the big picture. And with functions, neither do you, not all at once. You can focus on getting one tiny piece of the puzzle right. Once that function is working perfectly, you can just trust it. You can move on and think about the bigger problem without getting lost in the weeds.
And that's the whole idea, right? That's the core concept, decomposition. You take any huge, scary, complex challenge, and it doesn't matter if it's software or planning a wedding or building a rocket, you can solve it by breaking it down into smaller, self-contained, manageable chunks. Each chunk becomes its own function. So I want to leave you with this thought. This isn't just about how to code better. It's a mental model for making the impossible possible. Think about some big problem or goal in your own life right now. How could you break it down into smaller pieces, into functions? Master each small piece one by one. That's the real power we're unlocking here.